Yes, students, welcome to the second part of the lecture. Now, students, pay attention. In the second part, we are going to start with the concept of conditional probability. Okay, now students, pay attention. In the second part, we are going to start with the concept of conditional probability. Now consider the sample space of tossing 3 coins once. So we will have HH, HT, TH, TT into HT. All of you know, students, when we toss 3 coins once, the cumulative sample space is HT into HT. Again, if I multiply, then I will have HHH, HTH, THH, TTH, then HHT, HTT, THT, and then TTT, that is N is equal to 8. Based on this, I am defining 2 events. Event T, at least 2 heads occur. So we will have H, 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 TH, THH, and HHT. Total outcomes of E are 4. Event F, first coin shows tail. So all the elements starting with T, 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 H, T, H, T, and T, T. Here also favorable outcomes of event F are 4. Students, what I have done, try to understand. I have taken sample space of tossing 3 coins once or 1 coin thrice, the sample space is same. Based on the sample space, I have defined 2 events. Event T, at least 2 head occurs, and event F, first coin shows tail. Now both the events, students, event E and event F have 4 outcomes as favorable. Clear? Now what I am introducing, event F has already occurred. F has occurred or even. So event F has occurred first. And now after F, E occurs. So what we are accepting, that event F has already occurred. That is, the first coin shows tail, that is given. Based on that, event E occurs. So one event has already occurred. After that, event E occurs. So for event E, the sample space will be not total elements which are 8, but only the elements 4. Only 4 elements, sorry, which are the favorable outcomes of event F. So based on that, there is only one favorable, which is THH, and THH is already present in F. So if event E occurs after, students, event F, then for event F, which is having 4 outcomes, that outcomes will become the sample space for event E. And considering that we have only one favorable, so probability of E given F will be only 1 by 4 because one favorable and total outcomes of event F are 4. Now students, this is interpreted as number of elements favorable to E and F upon number of elements which are there in F. And this can be divided and written as n of E intersection F upon n of S and n of F divided by n of S, which is nothing but 1 by 8 upon 4 by 8, and still that is written as 1 by 4. So whenever we are discussing conditional probability, when the base event which has already occurred, after that the second event occurs. Remember, for second event, the sample space will be only the 4 elements which are belonging to the first event here. In general, for the second event, the sample space will be reduced to the first event which has already occurred and not the total sample space which is S. So what is the definition of conditional probability, students? Remember, let E and F be any two events of a same sample space S. Let E and F be any two events of a same sample space S. Then the conditional probability of E given F means F has already occurred, is denoted by P of E oblique F, and this formula is nothing but probability of E intersection F upon P of F on the condition that P of F not equal to 0, means F is not any possible event. So what is the definition of conditional probability? Students, try to understand. Let E and F be any two events of the same sample space S. Then the probability of E given F is denoted by P of E oblique F, and the formula of P of E oblique F is P of E intersection F upon P of F. The base event probability will always, students, come in the denominator. The base event probability, students, will always come in the denominator. Similarly, P of probability of F given E is denoted by P of F oblique E, and that will be P of E intersection F upon P of E, where P of E not equal to 0. Students, this is what we are to study in conditional probability check on page number 533. They have given, if E and F are two events associated with the same sample space of a random experiment, the conditional probability of event E given that F has occurred is P of E oblique F. Don't read this as P of E oblique F, read this as probability of E given F. Given F, given will always come in the denominator. This much, students, we have to remember. And now we study a few properties of conditional probability which are, students, given in textbook. Now, students, we will study few properties of probability. Conditional probability. And you say the first property is P of S given F is same as P of F given F equal to 1. Now see, students, probability of S given F is P of S intersection F upon P of F, and P of F S intersection F is P of F itself. P of F upon P of F shows 1. So the answer is 1. Even if I operate P of F oblique F, probability of F given F will be a sure event, certain event. its probability is log. Even if it is E given E, this would be the same. Now students, A, B and F are the events defined by a single sample space. You can say S. Now all of you know this formula. Probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B. So if this occurs on the condition that F has already occurred, then also students, this law remains safe, universal. A or B occurs on the condition that F has already occurred, then also this probability law remains universal. Now the third property, all of you know, probability of complementary event is 1 minus probability of that event. This occurs under the condition that F has already occurred, then also students, it remains the same. So thus are the three basic properties of conditional probability, students, which we have to remember and memorize. Now students, we can start exercise 13.1. So these three properties, you remember, third property and first property, very important for MCQs. So students, please try to understand and memorize this. Students, please try to understand and memorize. Now, exercise 13.1, answer 1. What is given? Given are events E and F such that probability of event E is 0.6, probability of event F is 0.3, and probability of E and F and its intersection, that is 0.2. First part, find probability of E given F. In second part, find probability of F given E. Okay students, now try to pay attention and try to understand the basics. Now probability of E given F, the formula is probability of E intersection F upon P of F. So this is 0.2 divided by 0.3. So this is 2 by 3 or 0.66 recurrent. So you can write 0.67. This will be P of E intersection F upon P of E, where P of E not equal to 0. So 0.2 upon 0.6. So 1/3. So this is 0.333 recurrent. So I can write it as 0.32. Students, remember, in conditional probability, the basic is to understand the concept, not only mechanically do the sum. Technically, remember the second event which occurs after the first, so that the sample space is reduced to the elements of first event. Really, that much students we have to remember. Okay, now students, sum number 2. Compute P of A given B. Okay, students, we have to compute P of A given B. Don't say A oblique B. Read this as A given B. What is given is P of B is equal to 0.5 and P of A intersection B is equal to 0.32. So according to the conditional probability formula, this is P of A and B upon P of B, where P of B not equal to 0. So 0.32 upon 0.50. So 32 by 50. So this will be 64 by 100. So this 0.64. Very easy students, very easy to compute. The main part of this type of sums is to understand the basics and apply the appropriate formula. Okay students, now answer 3. Now students, answer 3. P of A is equal to 0.8. P of B is equal to 0.5. And P of B given A is equal to 0.4. First is to find probability of A intersection B. Second part is to find probability of A given B. And third part is to find probability of A union B. Okay, now students, P of A given B can be written as P of A into P of B given A. Easily you can understand. Probability of B given A is nothing but P of A intersection B upon P of A. So if I cross multiply and make P of A intersection B as subject, I get this. So this is 0.8 into 0.4. So 32 by 100. So 0.32. P of A given B is P of A intersection B on P of B, and this is 0.32 divided by 0.50. So again this is 0.64, and this will be P of A plus P of B minus P of A intersection B. 0.8 plus 0.5 minus 0.32. So this will be 0.98. 0.5 minus 0.32 will be 0.1. So the final answer is 0.98 students. This is very simple. It is based on the formula addition law for two events. Okay, now students, some number. Now students, sum number 4. The given equation is twice P of A. Answer 4. Twice P of A is equal to P of B is equal to 5 by 30, and P of A given B is 2 by 5. Find P of A union B. Okay, we need intersection in order to find students P of A union B. So P of A will be 5 by 26. P of B will be 5 by 30. First of all, from P of A given B, I can write this as P of A intersection B upon P of B. So P of A intersection B will be P of B, which is 5 by 30 into 2 by 5. 5 ones are 5 threes are. So this will be 6 by, sorry. This is only 5, sorry. So this 5 and 5 gets cancelled. Sorry students. So this is 2 by 30. Okay. Now P of A union B will be P of A plus P of B minus P of A intersection B. So this will be 5 by 26 plus 5 by 30 minus 2 by 30. Take 26 as LCM. 5 plus 10 minus 4 by 30. So 11 by 26. Sorry. So this will be students 11 by 26. So students, these are short sums. These are MCQ based sums, which will be only useful for, you can say this type. These are concept based sums, and these are only MCQ part A of the paper, in subjective part, this type of sums are generally students not asked. Okay, now students, we are doing the last sum for the day. Many questions we will continue afterwards. The fifth sum, probability of A is 6 by 11. Probability of B is 5 by 11. Probability of A union B is 7 by 11. Find first probability of A intersection B. Second, probability of A given B. And third, probability of B given A. So students, in this type of sums, now union intersection can be interchanged. This we remember. Union intersection can be interchanged. So probability of A union B, then here intersection. Probability of A intersection B, then here union. So 6 by 11, 5 by 11, 7 by 11, 11 minus 7, so this is 4 by 11. This will be P of A intersection B upon P of B. So this will be 4 by 11 upon 5 by 11, so 4 by 5, so 0.8. And this will be P of A intersection B upon P of A. So 4 by 11 upon 6 by 11, so 2/3, that is 0.666 recurrent. Or you can write 0.67. So this is the total concept of conditional probability in terms of application of formula. Again I am saying, read P of A oblique B as P of A given B. Oblique is just the symbolic notation, conceptual notation for A oblique B is probability of A given B. Okay students, so here we conclude the second part of the lecture, and in the next lecture we will start from sum number 6 onwards. So students, this concept is very interesting, very easy also, so one must understand and do. Then students, this type of sums are very easy. Okay, here we conclude the lecture. Remaining we will do in the next